So, I don't have to introduce myself. I'll just say on the blog that since I joined the Power BI product team, I haven't had much time to blog. So that's why it's been very quiet over there. So I apologize for that. So I have a mandatory intro slide, but basically the reaction I get these days is, wait, I know you. You might see me, of course, I'm on social media, I'm in the team, but you might also see my ugly mug on the monthly updates. Like every month when we get a monthly update, you'll see me as the author for that, which is something that I love to do as well. So that's now I'm kind of getting famous and a bit recognized on that, which is pretty cool. So in the Power BI team, for those that don't know, I own the DAX and modeling space. So anything related to the programming language, the beautiful programming language that everybody loves to hate, DAX, and our modeling story, like relationships, the model view, but also composite models. That's basically my area. So I'm not a big visualization expert. I do have strong opinions on pie charts, but I don't own that space. It doesn't mean that I don't have an opinion or think we should, like have ideas on what we should be doing. But I don't get to call the shots over there. So I get to call the shots on everything modeling and DAX. So there's exciting things coming up on which I won't be talking because this is not a non-disclosure agreement session. But stay tuned. There's very, very, very cool stuff coming from the DAX and modeling space very soon, for which I'm very excited. However, we have to wrap up another feature. And one of the biggest features that I've been working on in this space has been in preview since December 2020, which is composite models on Power BI datasets and Azure Analysis Services, also known as direct query for Power BI datasets and Azure Analysis Services, because that's what it does. And since December 2020, we've been talking to customers and learning from how they use the product and how they use the feature. So I think it's time for us to kind of start talking about what we learned. So Ben, let me just get that out of the way right away. They are not going to be premium only. They are going to be premium and pro. As long as I'll be here, they are going to be premium and pro, because that's the stake in the ground. That's what we said from the beginning. Like Arun or Satya will have to twist my arm if they want it premium only. But if I can help it, if it's up to me, and it is so far, it will be premium and pro. But I can see where the confusion comes from, and I'll talk about that in just a sec. So basically, that's where we are right now. We have that preview running. So what I wanted to cover is what did we learn about how people use these composite models. So I'm talking about a very specific version of composite models, right? So composite models, in essence, already exist. If you don't know what a composite model is, very simply, think about those strong glues you can buy in any do-it-yourself shop, right? Those two glues, the glues come in two components. By themselves, they don't glue. But the moment you mix them together, it turns into glue, right? You have two tubes, one lighter color, darker color, you mix them together, you get the glue. That's a composite glue. And that's essentially what a composite model is. You take data from one source, you add data from another source, you relate them together. That's where you create magic and actual insight, which you couldn't get from either source. But only when you get them together, you have a composite, you have more value. That's where you created a composite model. And you could have done that already. However, the moment you connect it to a Power BI dataset or Azure Analysis Services, you couldn't. You won't get a composite model. Now, that capability is what I'm talking about here. That has been in preview since December 2020. And we're talking about composite models hosted on Power BI, mostly. That's what I'll be focusing on. So not everything here. This is very Power BI focused, but of course, you could also build a composite model on Azure Analysis Services. Slightly different rules apply. I'll be mostly focusing on the Power BI items. I will skip the demo for this because you've probably seen it a lot already. Otherwise, you can look it up on YouTube. There's numerous demo sessions that I did on that. I'll skip it in for the sake of time. So just to give you a couple of ideas of what we had in mind when we designed this feature. So we envisioned that we had three big scenarios. First scenario we labeled as extend, which is basically adding data to an enterprise semantic model. So when we say enterprise semantic model, we mean like a Azure Analysis Services model or a Power BI data set that somebody creates over in some team, and then some end user looks at it and goes like, you know what, that's great, but for my analysis, this small piece of data that I have somewhere here in this external data set or CSV or an Excel or some smaller database is missing. I'm going to add it I'm going to relate it, and then I can add the business value that I'm looking for. And that's what we call this extend scenario. Enrich is another scenario in which you don't actually add any data, but you change something about the model. For example, a format string. Here in the US, they have the stupid habit, I would say, at least for my European brain, stupid habit, to put the month first. So their date format is month, day, year. Not like it should be smallest to largest, day, month, year. But imagine somebody creates a data model here in the US and then shares it with you and your customers. They are not necessarily aware that they write it month, day, year. So you would maybe want to change the format string for the dates. That will be an enrichment. You then share that version of the model with your customers, and for them, that format string date then makes total sense. So that's an enrichment. The other one that we had in mind was overview. Basically, you take multiple bigger enterprise semantic model like data sets, and you just show them in one pane of glass, like a dashboard in a report, but not necessarily relating them. So no, you just keep them separate, but you show, for example, sales and HR chart and whatever other chart you might have on one pane of glass, but they're all coming from separate disjointed data sets. So that's the things that we had in mind. We also had things very specifically not in mind. We didn't design this feature to allow you to join two big enterprise semantic models, for example, with a common shared dimension table. We didn't have that in mind when we designed all of this. So also combining large dimension table and large fact table from different sources was not something we had specifically in mind. We've seen loads of customers do it. And of course, depending on your use case, it might work, it might not work, it might not perform well. We'll talk about that in just a second, but just keep in mind, we didn't have that in mind when we were designing this feature. Now going to some best practices here. How big is big, Fernando? I'll just get to that in just a second. Some best practices. First one shouldn't surprise you now with what I just said. Avoid combining multiple enterprise semantic models. Just because you can, just because the product allows you to, the feature allows you to do that, doesn't mean you should, because it wasn't designed for it. The idea was not for you to merge those two big circles and overlay them like a Venn diagram here on the left. The idea was to do what is on the right here, to say, hey, you have a big model, and then I'll add several smaller circles around it that enrich my data or extend my data, I should say. That's basically what we designed it for. Now, technically, you can absolutely do the left scenario where you combine two big enterprise semantic models together, but it wasn't designed. So your mileage might vary, right? It might change depending on your use case and, of course, how big your data is. And that's where we'll go next. Because when you create a link between two data sets, be it small, be it big data sets, so like two enterprise semantic models or an enterprise semantic model and a smaller data set, you will get what we call a cross-source group relationship. So any direct query source, if you don't know what a source group is, I'll just explain. Any direct query source, all of the tables from that source form one source group. So if you have two direct query sources, you will have two source groups. If you have one table from each source, you will still have two source groups. Then there's another source group, which is all of the imports. So if you have 50 Excel sheets imported, those will all be in one source group. So there's one source group for all of the imports, and then one source group per direct query source. And that's important because when you create a relationship that crosses source groups, either by relating a direct query source table with an import table, or by relating a direct query table with another direct query table, it exits the source group. It jumps from one source group to another. When that happens, those relationships are not optimized. And that's where the trouble starts. And that's where you have to be careful. Within a source group, so within all of the imports, or within a direct query source, so inside of one source group, there's loads of optimization going on where we can get you the performance that you're asking for. But the moment you jump source groups, there's interesting things happening. That's what we call a cross-source group relationship. You can find more about that in our documentation. We also call them limited. And the reason for that is because there's no optimization. And that's where the trouble starts, and that's where you have to start being careful. So when you build a cross-source group relationship, the key columns you use on either end of that relationship should have a cardinality of 50,000 or less. That's what we, our rule of thumb for that. So when I say cardinality, I mean the number of unique values, right? So let's imagine you have table A that has only unique values on one side, and then it relates to a many side on table B. Table A needs to have maximum 50,000 items, approximately. Of course, it won't break with 50,001, but if you go to 500 million, yes, of course, this is way above the limit or above what we in general advise you to do. We won't stop you from doing it, but in generally, we don't advise you to go over this number. So this means if you have a big customer list that you want to relate to a fact table where customers bought products, if that customer list is above 50,000 items, unique customers, then this relationship will suffer in performance. And the reason is very simple. It's because when we create this relationship across source group, what we do is we add the where clause. Let's imagine they're both like there's a SQL source on the other side with a large fact table. The where clause in the statement that we generate, the filter, we put in all of the unique values of the customer. So all of the 50,000 unique ideas of the customer go into the where clause. Now you can see that SQL statement that we execute there is large because it says select sales amount, blah, blah, sum of sales amount by customer ID from sales, where customer ID equals list of 50,000 items. You see now why this is not optimized, why this might turn into performance problems, because depending on your source, they might be happy or might not be so happy. Also, by doing a cross-source group relationship, that means that data about your customers, depending on how the relationship is being built, is being shared with the other source, because in the where clause, that key information that is required to filter will be sent to the other source. Great if it's your own source, but let's imagine it's your customer list. And for what weird reason you're relating on first name and last name combination of your customers, and then this list that you want to relate to is not owned by you, but by some other company. Because of this cross-source group relationship, what will happen is in the equivalent of the where clause, all of the customer names, first and last names, will be exposed to that source, which is okay in many cases, unless you only sell out of your 50,000 customers, only 100 have bought something with this company, right? Now, the admin or whoever is looking at the query logs in this source will see all of the names of all of your customers because all of them will be part of the where clause. Just something to keep in mind. It's probably okay, but that's why we show you the security warning. That's what that warning means. It means you might be exposing data you don't want to because of this cross-source group relationship if you create them. So when you build them, keep them under 50,000. So that's the answer to how big is big, Fernando. The other one is, and you should already know this, use a proper dimensional model. Like, so many people create a spaghetti model, don't use a proper dimensional model with Power BI. It's just setting yourself up for disaster. Power BI assumes you have a proper dimensional model, not a flat table, not a spaghetti model, a proper dimensional model with facts and dimensions, either a star or a snowflake. With multiple facts, it's okay, but just create one. It's true for anything you do in Power BI, but particularly for this feature. It optimizes for dimensional models. So, the moment you don't have one, you need to create one. Now, related to cross-source group relationships, you should really rethink where you leave your dimensions. So ideally, you should store your dimensions with the facts. So we have seen people have a source group that only contained the fact, for example, sales here, source group B, and then only the dimensions in another source group, like common dimensions, and split into two source groups so you can reuse them. If you do that, you create cross-source group relationships as a result. And as a result, you will have to think about like what it means when there's a cross-source group relationship and the cardinality of that. So if you can, you end up in this situation where all of your dimensions in one source group and all of the facts in another source group, consider moving them together. So moving the region and the customer to the fact sales source group, because then your relationship turns into an intra-source group relationship, not a cross-source group relationship, and as a result will be optimized. So Italians sometimes are good and sometimes are bad for Power BI. Well, I won't generalize too much over Italians, by the way. I'll have to be a bit careful there. Some of our best MVPs are Italian. Then when you create calculated tables, especially when you create virtual calculated tables, and I'll explain what that is in a second, you should keep them as simple as possible. So with this feature, what you're perfectly capable of doing is, as an extension, not only change the format string, but maybe add a new calculation, like a measure or a calculated column. So with this feature, you could connect to your enterprise semantic model and then say, you know what, I need to add a calculated column to my table, but it's not my own table, it's just the remote table, what we call it. We call it the remote, that's the one you connected to. So you are able to create a calculated column. We call that a virtual calculated column now. That thing should be simple. And the reason is because the data is not here. So what we do is we have to somehow calculate the whole thing while the data is somewhere else. So there will be loads of queries going back and forth to give you the values in that calculated column. And you should really ask yourself, if you do that, why am I doing this? And why can that calculated column not just be part of the source group to begin with? So best performance would be to move the calculated column you're creating outside of the virtual world, so outside of your local model, and move it into the remote model by itself. That would be best. But of course, sometimes you can't. Especially when using a group by, a filter, or an aggregation, you might get into trouble, like with SumX or whatever, those kind of things. If you start doing those in virtual calculated columns, you will get into issues very quickly because of, again, all the optimization that's not happening. So again, if you do that, think about it, you'll probably be fine. But if you get performance issues, this is one of the first places to look. Another one that catches loads of people out is this one. Because of the optimizations that we do when data comes from one source group, you should consider adding or limiting a visual to only data from one source group. So if you, for example, have product and sales in one source group and product and cost in the other, you will be tempted to create a relationship, a cross-source group relationship on product, which is probably fine unless you have more than 50,000 products. And then you probably are tempted to maybe show a diagram or a chart to say, hey, for each product, what's the total sales and what was the total product cost that we had? When you do that, those calculations will leverage the cross-source group relationship. As a result, won't be optimized. Maybe, if you can, it's better to just create two visuals. And yes, I know it's not best practice. And yes, I know it uses screen state that you'd rather be using for something else. But maybe it's better to just create two visuals that give you exactly the same information, but then each visual is separate to its source group. So the left visual is only from one source group, the right visual is then only from the other source group. They show exactly the same information. Yes, your product name is repeated. You could hide it, probably with some trick. But if you do that, if you split it out into two visuals, both of those queries will be optimized. The moment it creates, you link data from one into one visual from multiple source groups, it won't be optimized. So it's just something to keep in mind. You could do that, but it's not something that we've seen people create performance problems this way. Okay, so let's see. There's some special considerations out there as well that I wanted to share for this. By the way, I needed to go back to the build question. That's a question I get a lot. There's actually two questions about this feature out there. One is, when will this go GA? When will this become general available? That's a question I won't be able to answer here because this is being recorded in public. If you want that information, you're under a non-disclosure agreement, talk to me offline, send me an email. I'll be happy to tell you, but I can't tell you right now. That's the first question. The second question is, what's going on with that build permission thing? So if you have looked at this feature before, you might have seen that if you build a report using this feature, and you shared it with somebody, and they just needed to view the report, that you had to give them build permission on all of the models that were related in this report. So if you had your report linking to model A, which in itself linked to model B, then user U had to have build permission on all of those models. That has changed for premium and premium per user workspaces. So for premium and premium per workspaces, that is now just read, as it should be. The reason, by the way, it was built is because we use the XML endpoint, and the XML endpoint allows you to do loads of things, but it requires build permission. So that's how we have changed that now. We're still using the XML endpoint, but we have a trick. We can now just talk to it using read. So you can now just give people view permissions, and that's it for premium and premium per user workspaces. And that, of course, sparked I think it was the first question here in the chat, is like, but wait, you guys changed that for premium and premium per user, but does that mean that this feature is not going to come to Pro? And I want to emphasize that's not what is happening here. The reason that we haven't done this for Pro yet is because of technical infrastructure challenges with Pro to make this happen. I cannot go into details because it's non-disclosure information. We'll solve it. It's just a matter of time. And then you will see exactly the same behavior as you have on premium and premium per user now in terms of permissions as on Pro. So by the time, that's actually the biggest blocker for GA. So by the time we go general available, this behavior for this feature will be exactly the same between premium per user and Pro features. So that's basically what's our workspaces. That's what's going on. There's other things that are coming. Oh, my dog is joining me here. Hello. I have an office assistant. Sorry. There's other things that we've got coming. We've heard people wanting to have more control over when this feature is being used. As you might recognize, if you're an admin in your organization, you don't have any tenant switch. You are not able to stop people from using this feature. That will all come very soon. Within like a couple of weeks from now, you will see a tenant switch coming up where you can actually disable this feature so people cannot build any new reports using this feature. However, existing reports will still be created. Now, I know we should have shipped this from day one with a switch that allowed you to disable this feature, but unfortunately we didn't. So now we're getting to that point. So some special considerations, and then we can open it up for more chat. When you use Excel using this feature, keep in mind that Excel generates MDX. And as a result, MDX in general are less optimized than DAX queries. So this feature will just perform a little bit worse when using Excel when you compare it to Power BI. Because Power BI will use DAX, Excel generates MDX. It's just, it won't break. It's just worse performance when you compare the two. Especially when you start working with slicers and convert to formulas in Excel, that's where the real trouble really starts here. Now, this slide also talks about non-wholesale and wholesale. And that's something that I have to talk about as well. It's not something that has an official name, so we just call it wholesale and non-wholesale. I know the people over in SQL BI call them wholesale and retail. It's nowhere in our documentation, which is on me. I'll have to write that down at some point. But basically, the way to remember this is if a measure or a query that is sent to generate a visual only relies on information in one source group, it is considered wholesale. If it's not, it's non-wholesale. So a measure that only refers to a remote model, even if it's locally defined, is a wholesale measure. A measure that's remote and only refers to a remote model is also wholesale. But a measure that's locally defined, that uses data from your one source group, your query source, and data from the import, is non-wholesaleable because it has two source group that it relies on. The same for the visual. That's why I showed you the example that you should split the visual into two, because that query for those visuals will now be wholesaleable. As a result, it will be optimized. When the visual depends on two source groups, it is non-wholesaleable, and as a result, won't be optimized. And that's an important thing to notice, because there's very interesting things going on with non-wholesalability measures and calculation groups. So we'll talk about that in just a second. So remote measures, so measures that are defined in your enterprise semantic model that you connect to, are treated as a black box. So if, for example, a calculation group is being applied, you don't necessarily know. And that's an important thing to keep in mind. Also, all selected and the all feature without parameters, the functions without parameters and remote measures do not work with calculated columns added to your local model. Something to keep in mind. They will just not work. And then dense measures, which are measures that always return a non-blank value, or partially dense measures, so they almost always return a non-blank value, may cause performance issues when they are non-wholesalable. So again, it goes back to rethink your visualizations and rethink the measure definitions to see if you can make them wholesalable as much as you can, which means making them depend on just one source group. Either the visual query needs to be one source group, or the measure query, the measure definition needs to rely on just one source group. Sometimes you can't, of course, I get it, but in general, if you want to get the best performance, make them wholesalable. Now, for calculation groups, today, the moment you use calculation groups with this feature, you switch them over, all formatting will be lost. So the moment you create a calculation group and then switch to a remote model or use a calculation group from a remote model, all formatting is lost. It's a bug. We're working on it. Will be fixed soon. But the problem really is with measures and wholesalability. So look at the bottom example here, the DAX statement. Here we have a local measure, which is total sales, which is very simply internet sales plus reseller sales. Very simple. Internet sales itself is a local measure. Reseller sales is a remote measure. Now, reseller sales is remote and only depends on objects from the remote measure, so is wholesalable. The internet sales is a local measure, but might or might not be wholesalable, doesn't really matter. But total sales by definition, because it refers to something that's local and something that's remote, is non-wholesalable. Now, the problem with this is the moment you add a calculation group in the remote model and you apply that, it won't be applied to internet sales. Because the internet sales is local, the calculation group is remote, it won't be applied. As a result, total sales might give you very weird results because reseller sales still responds to the calculation group. So let's say we have a calc group that goes from actual to year to date. And if I select year to date, reseller sales is now a year to date result. But internet sales isn't. It's just actuals. So now what I'm doing in total sales, I'm adding an actual number with a year to date number. That I'm pretty sure that is not what you intended. And that's something you have to be very, very careful about because it is not easy to understand, A, if something is wholesalable or not, and B, if a calculation group is being applied. So there are some things you have to think about when you create calculation groups with this feature. You might very quickly shoot yourself in the foot. So just keep this in mind. You can reread the slides. I'll share them. There's more details in here. We also have a webinar coming up where we spend 20 minutes just talking about this one thing to give you some more examples. It's just something that we've seen people asking over and over again. Another one, when you filter across source groups, keep in mind there's some patterns that are not supported. You cannot have the same table in one source group. In this example, calendar here on the top right, filter two tables in one source group. So calendar can either filter budget or sales, but not both at the same time. Now, if you look at the bottom, the other thing is you cannot go from one source group, exit the source group to filter, and then re-enter the source group. So you cannot go from region in source group D to filter customer in source group C to get only the customers in a certain region, and then use that customer list, that filtered customer list, to then filter the sales table that is in the same source group as you started in. So that kind of like back and forth is not allowed. We will actively block you from doing this. Way to solve this is just to move customer into the source group D, or to move region into the source group C, or everything into source group C, whatever you want, or sales with the customer, that's fine as well. But just this like going back and forth, exiting and re-entering is not allowed. So that's basically some of the special considerations that I had here. So in summary, and then I'll keep my mouth shut for a little bit. It's very powerful, but this feature has specific challenges that you have to think about. Follow the best practices. Keep in mind the special considerations. The moment you see performance issues, think about wholesalability versus non-wholesalability. Your calculation group playing interestedly with those like definitions of what's remote and what's local. And also look at your cross-source group relationships because they might just be very big. So there's some documentation links here for you, links to the docs, both on the current feature as well as the best practices for all of the composite models, and this information eventually will go into that docs as well. So with that, I'm gonna shut up and I'll open it up for questions.
All right, thanks very much for that, Jay. So I think there's probably just one question that may be unanswered. So Kumar asked, I think going back to your page where you had the sales value and the sales cost in two separate visualizations, and his question was, would a calculation group give better performance to show the sales or cost?
Sorry, can you say it again? To show what?
Yes. So I think that the question was, would a calculation group give better performance to show the sales or the cost?
Yeah, it would, but the problem is, where do you define the calculation group? Because
right, okay.
If I have, let's say my blue one is my remote model and my yellow parts are my local model. If I define a calculation group in the remote model, so in the blue parts, and I change that from sales to cost, cost won't be affected because it's in my local model. So the trick here is then to rethink where you should put your data. And if you want to do this trick, that calculation group will have to reside in wherever that data itself lives. So then you would have to move cost into sales. So you would have to move the yellow one into the blue model, which kind of negates the whole purpose of connecting them in the first place, probably. So yes, of course it would improve performance, but that calculation group will play nasty with working across those two things, unless you can guarantee that cost is wholesalable. If cost is going to be wholesalable, so it's only referring to just one source group, the remote source group, the blue one. If that's the case, then this will work. But other than that, it's very easy to shoot yourself in the foot and go create cost as a non-wholesalable measure and then think that your calculation group will actually impact it, which it won't.
Okay, all right. And then I think another question that James just asked, and Raoul was also interested, just a further explanation of what a dense measure is, if possible, because it seems to be a new term potentially that people aren't familiar with.
Well, a dense measure is just very simple, actually. Think about, let's say you do, I don't know, just sales, total sales, right? You have a sum X on sales, fine. As long as that measure always returns a non-blank value, so always returns something, a numerical value, doesn't matter. As long as it's not blank, that thing is called dense. The moment it can at some point return a blank value, so not numeric, it is not considered dense. And as a result, dense measures are dense measures are better optimized than non-dense measures, right? And if you do non-dense measures, if you do dense measures, so they are all returning a numerical value, in a cross-source group with a non-wholesalable query, and this is very weird because now I have dense cross-source group and non-wholesalable in one sentence. But if that happens, if you have non-wholesalable measure definitions that always return a value, so never return a blank, there can be performance issues. We've seen many people opening support tickets because of that situation. And I'm not blaming people for opening support tickets. It made total sense because this is a very complicated scenario. It's really hard for you as an end user to understand what's happening here unless you are, one of the AS gurus, like the engine gurus, like who write books or on our product team. They will easily understand how this all works, or easily, quote unquote, easily. I don't blame you for doing that. We can do better as a product as well to help you a little bit, but that's basically what you have to keep in mind.
Okay, and then just to, and probably for my own clarification as well, so dense measures, would they only relate to iterating functions, or are they for aggregating functions as well?
It's also aggregating functions.
Okay, fine.
As long as it always returns a value, then it's considered dense. It's just something that we have in our internal vocabulary. We have always used dense versus not dense because it has impact on how the query is optimized, very simply. And it's just something that is now surfacing because of how this feature is being built and this feature being very complex and very powerful. You are now exposing to more of the internal organs, if you will, of how this engine works. So yeah, it's just something to keep in mind.
Okay.
So a non-dense measure is a measure which can return a string. Yes, exactly. Like a measure that can return anything is a non-dense measure, right? So if I create a measure that might return an integer at some point, but that also might return a blank, it is a non-dense measure. If I have a string, and that string is guaranteed to never return actual blank, so not just an empty string with 2 quotes and a space or just 2 quotes. If it returns a blank, it's non-dense. So a measure that returns a string, calculate a column that returns a string, can definitely be dense because it can always return a value. But the moment it returns a blank, it is considered non-dense, basically. Will the MS documentation be updated soon? Yes. I'm still learning about all of these best practices and all the numbers that are in here. Also, some of the things are still under change. For example, with the formatting thing for the cal groups being lost, we'll fix that. Also, the going back, the exiting a source group and re-entering, the last example that I gave you really quick, is also something that we're debating on fixing. So that's why it's not being written in the documentation yet, because I only want to put in the documentation that will actually be problem scenarios when we get to GA. So yes, by the time it's going GA, all of this will be written in our public documentation, as well as wholesalable versus non-wholesalability. That is something you today can only find on SQL BI, which I don't think makes a lot of sense. Not that their article isn't good. The article is great, right? I mean, I'm not saying anything bad about that, but it's just weird for me. Our documentation should at least list these concepts. If not, do a better job of explaining them. But maybe we can't, and that's great, but we should at least list these concepts so you have something to go on and find the SQL BI article. So let's see. Is there anything else in the chat here? Analyzing Excel, is that supported? Yes, that's absolutely supported with the new the composite model feature.
Okay. And I guess one other question, and just something that kind of came to the back of my mind, and it maybe come down to the kind of data modeling and deciding where you're going to put the data and everything else. But would aggregations help solve some of the performance challenges in any way, or does it then also depend where you decide to put your aggregations?
Well, your aggregation can absolutely help to reduce the cardinality on your cross-source group, right? So if you somehow are able to use X to reduce the number of unique values of the relationship of your cross-source group relationship, so if you're able to reduce the cardinality of the key columns on that cross-source group relationship to go under that limit of 50,000, yes, absolutely, aggregations will help. And then it doesn't really matter where they live. Of course, the rule of thumb is basically it's like an adaptation of Matthews Roach maxim, right? Do it as far upstream as you can. Do it as far low stream as you have to, downstream as you have to. If you can do an aggregation, you can do that upstream, and you can answer all your business questions, then of course do it upstream, right? So yeah, but you can definitely do it downstream as well and use it there. And that might be a trick to get that under that, like this, what we call out the limitation, which is, of course, we won't break the product for you, but in general, we've seen that 50,000 is kind of the limit here.
Okay.
And that limit is, by the way, especially important if you have string columns as keys. So if you have customer name as for example, first name, last name as the key column for your cross-source group relationship, that limit of 50,000 is way stronger than if you just use integers, right?
Yeah.
I don't think you should ever use a string column as a key, but sometimes it happens.
Very
okay.
True.
I see there's one more. Raoul has an off-topic question. I don't know what the question is going to be about, but let's see.
Yeah. Go on, Raoul, let's hear it if you can. I can come off mute and ask if you want to.
Yeah, of course. You don't have to type the whole thing. I wonder if the question is going to be, where did you get this t-shirt?
Maybe. Hey, Raoul.
Can you see me?
Yep.
Yes, yep.
My question is, please explain your passion about the pie charts.
I thought so already. Can I? Sure. It's a pretty long answer, but I'm not the only one, by the way. I don't know if you ever heard of Stefan Few, one of the data visualization gurus. He wrote an article a little while ago. It's called "Save the Pies for Dessert," and that's exactly what it is. So the problem with pie charts in general is that pie charts use angles for us to understand the difference between the various slices. Now, problem is that angles are not something that our brains are trained on. If you go back into how our brain operates, it is actually really good at understanding straight and horizontal, like vertical and horizontal lines. Within, like, before you even think about it, like in terms of brain energy, you will know if this line crosses or not. You'll be able to see that right away. You will be able to see this difference. You'll be able to see this difference, but this difference is not as easy. So that's why we add labels. So we tell you this is 24%, this is 25%, but it's really hard for us as a brain, in our brain, to operate on that. That's why, for example, if you think about a pie chart, it's just a clock, but then many slices. How many people can read a clock, minutes and hours, without any dashes around it or any numbers around it? Just take a white circle, put in two dark lines, and try to indicate the hour. Right? If I do this, yes, of course you will be able to understand what the hour is. But if I move it slightly, are you able to exactly pinpoint how many minutes before? What is it? It's probably reverse for you. So 9 it is for you, right? You won't. And that's the problem. Because in a pie chart, in a data visualization aspect, that slight difference might be millions in difference. That's the issue. That's why we add the lines and the numbers around the clock. Now, 5 slices or 20 slices. So then we add labels to help you understand it. Shouldn't we just be fixing the visualization and instead give you one that actually works for your brain without having to require all of these things that help you understand it while also wasting loads of space on your canvas? So multiple problems. It's not wired for your brain, or your brain is not wired the right way. That's the actual way of saying it. It takes up a load of space, and they're just plain ugly. No, but the last one I'm joking about. But it is true from psychology and how our brain works, is that we're not really good at understanding angles. And this thing relies solely on angles, nothing else. And that's why it's a problematic visualization that you should definitely reconsider to convert into something that uses straight lines, like a bar chart or a tree map, which is almost always, and of course on social media I'll claim it's always, but I'll be more nuanced here. It's almost always the better visualization. So that is kind of like a whirlwind explanation of what's happening. If you want to learn more, I would definitely look up Stefan Few, the pies, keep the pies for dessert, something like that. Save the pies for dessert, I think is the white paper he wrote years ago. And you'll see I'm not the only one.
So there are some scenarios when you would say you do use them. I don't
No,
think so.
I never use them.
So I mean, Power BI, Microsoft has the intention to give us the possibility to use it. So I'm always curious, like, when should you use it? Because my job, the one that gives me the assignment, when I show him a pie chart, he's very quickly like, we have to act on that, and after that I go drilling down. So I don't use it often. I don't have it in my reporting, but I'm just curious because I've seen some more data guys like pie chart.
No, and this is the reason, right? You use a lot of real estate. So out of your like room that you use a lot to have less quality of information, less density of information in the pixels that you have available to you on the report. Also, I think there's multiple questions that you actually ask within your question. I know managers have been like fans of pie charts. There is a weird research from a little while ago, which was never repeated or never done again, so it's probably not real research. But that claimed that actually, if you expose two groups to the same data using one group solely on pie charts and the other solely on anything else that is not a pie chart, so anything that uses straight lines, and you do an IQ test before the test starts and after, that research claims that this group that looked at pie charts solely has dropped in IQ. And that's maybe why managers are so... Anyway, I'll let you finish that. But that's kind of the problem. They're not data visualization experts. You're the data visualization expert. If anybody asks you for a pie chart, you should definitely push back if it's above 3 slices. I'm okay with doing 2 slices. I would personally never do it, but 2 is okay-ish because then the angles are very broad by definition, right? You'll be easily be seeing the difference between this versus that. You can see that. It's not like the devil is not in the details, right? The devil is in the details. That's the problem. A donut chart is even better already than a pie chart because what it does, it's just a pie chart with a white circle. And the reason there's a white circle, because it gets away of the angles. You get just bigger, basically you can look at the outset, which is always a bigger change than just a tiny angle that is different. So there, a donut chart is already an improvement. Now, the other question you ask is, why does Microsoft offer pie charts? If you're so against it. Well, I'm not the only one on the product team. Let me be very clear on that. That's number one. The second reason is when we sell our product, we get asked questions on which visualizations we support as a list of to be considered for buying for a customer. And then, do you support pie charts is always on that list. So if we said yes, then we sell. If we don't say yes because we don't support it, we'll never sell our product again. And that's just a sad reality. And yes, the list of questions that we have to answer when people are considering buying a new data visualization tool like Power BI is that detailed. It really asks about which visualizations do you support. Pie chart is always on the list. So I hope that gives you kind of like insight on why.
Well, thank you for the whole session, though.
Yeah, sure.
And just one more question is sneaked in if you have any more time, Jay, if that's possible. So are there any, and it's from James, so are there any row-level security considerations or limitations that we need to think about for composite models specifically? And I think there may already be some documentation around that, I think.
Yes, there is actual documentation around that. It is currently in our on our blog post and on the documentation on this feature. Let me just look it up what the latest status was. To be honest, I'm kind of lost on that. Let's see. I think the problem here is that RLS, when it's defined in the remote model, doesn't get applied to local. I think that's the problem. So let's say you have or was it the other way around? Now I'm tripping myself up. Let me think. Remote always gets applied, obviously, only in remote sources. So if I have, for example, a country list in remote, and I have an RLS rule, that will still be applied. That will be used to filter local, let's say, sales data that's in my local table. But the other way around is not true. So that's the trick. I can define an RLS rule that will filter a country table that's remote, but that won't be applied. So the local rules don't flow to the remote. That's the problem. So you are definitely able to just define an RLS rule locally, but it won't be applied to the remote sources. So you have to be careful there. Now, luckily, anything that's already remote will be applied. So you cannot like strip out the RLS rules somehow using tricks. That's not, you cannot do that and expose more data than you're supposed to do. That's not what it will do. But the local doesn't flow to the remote. That's the problem.
Okay. And in some ways, it makes more sense that the RLS on a remote model is the one that takes precedence because that's your bigger semantic model.
Yes. So let me be very clear. That will always be applied, right? There's no way for you to create a local RLS rule that somehow strips off the remote RLS.
Remote one,
right?
Yeah.
That's never going to happen. At least if it happens, it's a bug, and I want to know about it.
Okay. All right. I think there aren't any other questions. So thank you very much again, Jay, for your time. Pleasure as always. And thanks everybody else for joining. I hope you found it really useful. It usually takes about kind of 5 days to get the recording up on YouTube. And we'll put it out on Twitter and LinkedIn when it is available. So thanks everybody. And we'll see you again.